The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlin.com and navigate to the Resource Center. Parker Sporland, leading the charge.
It definitely feel like I'm dying. What's that? Oh my god. New year, and good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. How are you?
Not too bad. Just fucking thrown off the middle of the week, day off. I hate these holidays where it's in the middle of the week and then we're off for a day and then back to work for 2 days. Holidays on a Wednesday suck.
You working tomorrow?
Yeah.
I think we're finally back to work too.
No, we're busy. We worked yesterday all day, and we're working tomorrow and Friday, doing a bunch of case changeovers. So
nice. I had back pain for the past couple of days, and I don't know. It just started progressively getting worse, and I went to the ER because it wasn't like the first night I was like, oh, I'm old, and I probably slept the stupid way or something, and I thought something was up, and so I let it go a second day and then third day, and then I went to the ER, and they were like, you have pancreatitis. I was like, cool, what do I gotta do? And they're like, you gotta not eat anything for 4 days. So I've been drinking beef broth, chicken broth, vegetable broth, Jello, and ginger
that sounds
ale.
disgusting.
Absolutely. It's just wonderful. I was so tired last night, I fell asleep, like, at my desk. I was sitting at my desk. I was trying to get some work done. And I was dreaming. I know I was dreaming. And then all of a sudden, like, I'm getting woken up abruptly. I've passed out right here at the desk, and my daughter thought I was dead. She's like, I thought something was wrong. You weren't breathing. I was like, I'm pretty sure I was breathing. I just wasn't snoring as usual. So
That's how you're going to go. Dead at the computer.
you think so?
More than likely.
Don't say that. That's awful. She's going to watch this and she's never going to want me to work ever again. You can't go near the computer. Kevin said you were going to die. Last week we did just an intro to oil stuff, the oil system and stuff. So we'll talk, I guess we'll get into like how to check oil pressure, and then we'll look at maybe some issues that we can resolve via that. So I guess we'll get right into it.
Let's do it.
Let's do it. Percent. If I slump over, you know what happened.
Don't do that.
You didn't take that I texted you. You're like, yeah, what's your social security number so I can get some life insurance? Prick.
It's going to be pretty expensive. You got a lot of hard living on you.
Yeah, a lot of street miles.
Jesus Christ.
All right. So first off, checking oil pressure. Are you going to check via the pump pressure and we want to be on the crankcase, but Kevin had said before that typically I've probably seen 20 compressors that maybe had a port on the side there for actually checking it. It's usually like 2 or 3 pound differential between the crankcase and the actual suction. As long as you're on the suction and not like on the filter dryer, if there is a filter dryer before the compressor, you should be straight. But yeah, you just want to get as close to the crankcase as humanly possible. Like I said, I've never met someone who's, oh yeah, there's no tap there. We have to put a tap there. Like you said, usually there's not one there. Depending on the compressor, most of the compressors fail out at 9 psi. No, is it 9 or 12?
Some of them are 11, some of them are 9. It really just depends on what it is. The Copelands, I believe, are like in the range of 10 to anywhere from 9 to 11. It just depends on the switch and series of switch, and it just depends on what you're using. But generally, now it matters what oil switch goes on one compressor, guys. There is Carlisle's get a lower oil pressure switch range than a Copeland.
Mm-hmm.
Bitzers and Copelands are pretty much interchangeable for the oil safeties.
No.
Yes, they are.
Okay, so if we're talking electronic, no. The electronic ones, the length of the probe that actually goes within there. If you're
That's
talking
different, but the actual like electronic part of it, like you could take a Syntronic 3 and plug it into the clip on the Bitzer.
Yes,
and it works.
It's the switch. And so a lot of people don't understand this too. The switch isn't like they call it a oil fill transducer. It's not a transducer. It's a differential switch. That's all it is. So it's set up in such a fashion that it's made to open up if the differential is lower than whatever the number is. Those switches, yes, they do have a different pressure range, but they all also have different lengths. Some are longer than others. I can't remember if the Bitzer one is longer or shorter.
I think it's shorter.
Yeah.
I think I remember it being shorter.
But if we're checking the differential, like in this instance right here, we have 85.5 pounds on the discharge of the pump pressure, and then we have 44.3. So it gives us 40.2 differential between the two. And so that's how you would check it. Typically, you're going to get anywhere from, depends on how old the compressor is. I've seen 25 and still running fine. Nothing physically wrong with the compressor, just old, everything's wearing out. From a brand new pump, you should get anywhere from 35 to 40, somewhere in that range.
From a brand new pump, Copeland,
Yeah.
50 to 40. If I see anything lower than 40, it's going back.
Yeah.
Like it's going back. If it's below 45, I'm like disappointed and looking to see if something's going on.
Yeah. Some of the things that might cause the pump pressure to be too low would be a pickup screen issue in the bottom of most of the compressors. I want to say all has a pickup screen in the bottom that basically the pump suction sucks from the bottom of the crankcase of the compressor, sucks that oil up within, goes up within the pump, and then pushes that oil through the crankcase, through the connecting rods, up into the pistons, the wrist pins, and everywhere else. If you were to have a good oil differential, but yet the compressor keeps failing, other than just a bad oil failure switch, I've seen where, and this has happened quite a few times, either after a retrofit or when someone puts a brand new oil differential switch in, there's an O-ring that goes around around the sensor. It's going to look like this. And if that little O-ring right there is not on that part right there, or is cut or damaged or shrunk from switching from one refrigerant to another, it will essentially cause you an oil failure.
Yeah, no, it's I see guys miss those. New guys all the time miss them when they put the switches in. They forget to put the O-ring on, or they clean it, and somehow when they're taking a rag the outside of it, they pull it off and they put it back in, don't notice. But I always inspect those when I take them out, because that'll really get you. On the Bitzers, the Carlisles, they all have a version of this sensor. So just make sure that when you take it apart, it's the same thing for all of them. It'll cause low differential. Same thing with the retrofits. I see a lot of guys not change them on the retrofits. They don't change the O-rings on them. Yeah, it's sealed and internal, but it's an internal seal failing. And it's almost worse than leaking, because if you forget these, then it's just random. They start randomly having oil issues.
Agreed. There's on the Carlisle, some of them have the one where they're plugged in just like a regular Copeland or a Bitzer, but then there's another one that can go on the front of the oil pump that just it's I'm looking for the brass piece now. I can't.
That thing sucks ass. They all leak. Oh my god, I hate doing those blocks on the Carlisles. Like it's like an 80% chance it's gonna leak. If they give you the steel gasket, I just throw them away. If it comes with it, I found a place that was getting the paper gaskets, had them in stock. Yeah. I cannot get the steel gaskets on any of them to seal. We did 35 or 40 of them, and we ended up taking the last couple to a machine shop and having them decked because the actual blocks were fucked up. Like they weren't plain.
Oh.
So the guy took it over an end mill and planed it down, but it was like a few thousandths of an inch out of tolerance, and it was enough where it was causing it to leak.
No shit. Here, let me share that one real quick. Present. So you can actually see what I'm doing.
Which is super frustrating when you're already taking this thing apart like 10 times to make it work.
Entire screen.
Same screen.
No, I know. I'm getting there. I'll do something.
Yep, that's the guy. That aluminum block.
Yep, that ended there.
Yeah, steel gasket, throw it away. Get a paper one.
So I will tell you, someone asked me how these things work. This is the Cure1 Delta P2 gauge. There's actually a spring in here with a little piston, and this is basically a proximity sensor is really what it is. So if you have the correct oil pressure, it will push the piece that's in here that's on the spring away, and then we'll say that it's outside of its proximity. And so that's what tells this thing whether it's failed or not.
What's fucked up about those things is like half the time the red light works in the back the correct way, and then half the time it doesn't.
What do you mean?
The red light is on there is usually a failure.
But no, every single one I've seen where
some of them it's a failure. Some of them it's not. Some of them it's good. And when it's flashing red, it means that there's an error with the proximity sensor. It's off, usually off kilter. But you got to watch because some of them flash red, or some of them are solid red when they're an alarm. Some of them are not red at all.
So you're talking, okay, this is where I got confused because blinking bad is usually where I always remember. I was like, blinking bad. And then I saw the Ray Corp liquid pump overfeed racks, and I thought it was the same exact switch, but it wasn't. So you're right. On the other ones, on those, they're switched because then blinking means that it's missing a level.
Correct. So like the Cree ones there was an older version of those where solid red is alarm. And no light is running. But the newer version, it's the opposite way.
Newer version of the oil one or newer version of the level
the oil one.
Really?
Yeah.
They need to come up with a standard. I'm tired of all this stuff because everyone's like, HB, we're like, hey, we're going to do what we want. Hey, Cure1, we're going to do what we want. And everyone's, red's always meaning bad. Why are we doing this?
I don't like the anything Cree1 makes.
I don't mind the Delta Ps. I don't mind the level indicators that are on the Bitzers. I got no problem with those.
The oil floats are the worst product I've ever dealt with in my entire life, with the least amount of support and hardest thing to use. It's ridiculous. Use a smartphone to program an oil float.
Can't be that bad, is it?
Oh, it's pretty bad.
No, I'm joking. Totally joking.
Yeah. Oh, just these 900 parameters. Yeah, okay, because that's going to get done in the field.
Yeah. So you can also have a blockage in these as well. You can have some debris that has accidentally went into the switch. So that's why when you pull them out, if you
backflush them from the screen out
with oil,
with degreaser.
Okay.
Loads and loads of degreaser, just fucking hammer down the can.
But just make sure that you have, that you pull off that rubber, if that would be the case. Because otherwise the degreaser can damage that. Are you laughing because you don't agree?
I just don't. I'm not going to lie, like half the time I don't pull the rubber off.
That's awful. So this is essentially what on this one. They're showing a nut on this Bitzer, but usually on the Bitzer it's like an 18 millimeter or something like that for the oil pickup screen.
Or it's a Allen key, metric Allen key, which really sucks.
Isn't that what I just said?
No, you said 18 millimeter.
Allen key.
Yeah, but it could have been a bolt.
Oh, all right, fair enough. Fair enough. All right, so we're picking up oil up through there, shoving it up through the pump, going through the crank, going through the wrist pins, the connecting rods, and that's how that oil system works on that one.
Yeah, if you have low oil pressure, the first thing I usually end up doing, I went too far in pictures. If you have low oil pressure, the first thing I'm grabbing is that pickup screen and cleaning that out. Just if you're having repeat nuisance failures, and even if your oil pressure is somewhat okay, I'm still going to go clean that pickup screen. Now, I do them in such a way that would give most people anxiety.
Oh, God, here we go.
I hook a vacuum pump up to them.
Oh, I do the same thing. Never mind.
And I turn the vacuum pump on. I pull the cap off just almost all the way till it's like the last two threads. I get a pick ready, and like a curved pick or 90-degree pick, and I pull it off while it's in a vacuum. I shove the pick in there. I pull the screen out real quick, and I put the cap back on. The act of pulling a vacuum through the suction in discharge ends up taking the oil, and it holds it in there. It's holding the surface tension, basically. So it has nowhere to vent out to go. It's like cutting a pipe, and it's got nothing open on the other end, and more likely the water is just going to stay there after the weight of the water just drops, because there's nothing for it to allow it to vent out, to break the seal to go. Now, if you're slow about it, absolutely, it's going to go everywhere. But I've even used this changing oil pots. If you're quick and you get it sealed back on the side and you're just holding it, the oil's not going anywhere.
I agree with that.
Until somebody accidentally unplugs the vacuum pump and while you're doing it, and you just get an absolute bath. So,
yeah, that's not a fun time.
No, but that's how I pull the pickup screens. That way I don't got to drain the oil down. And if you want to be a little bit safer and take more time, I just use the oil pump to drain the compressor down. I just shut the oil pot off, hook a hose up to the discharge of the oil pump, and I push it into the oil reservoir or the suction farthest away from the compressor to try to drain it down. I let it go till it goes off on oil failure.
And you do have to watch if you're pumping it into the suction. Make sure that you are the farthest away, or you're pumping it somewhere farther away from the compressor. Because I've had someone, where they're trying to pump the oil out, and they're like, "I don't know what the problem is. It just keeps filling back over the oil. I think the valve's leaking." No, you're getting oil back from the suction. I have also, depending on, if it is a low pressure oil system and you do have a reservoir, and I had an argument with someone because they're like, "You can't do that." I was like, "Yeah, you do. If you were to bleed the pressure of the reservoir all the way down to suction, and then pump that oil from the compressor into the reservoir, then you don't have to worry about it actually entering back in through the ass end of the compressor."
Yeah, it's not a bad idea.
Yeah, it just I'll have a stationary set of gauges when I'm doing an oil change, just so I don't have to deal with, because I'm trying to get every bit of old oil out. So if I have a compressor that I've already done, trying to get that oil out, then that's what I'll do. One more thing let's talk about before we go to the sling style compressor. You have a motor protector up in the pecker head typically. You can get oil failures due to that, depending on how the system is wired up. That compressor can warm up, whether it be from blow by from another compressor, and essentially warm up the windings within the compressor, which essentially warms up that sensor and then fails out that motor protector, in turn killing the control circuit. So be mindful of that. This other compressor, they use something similar to that Delta P gauge, except for it's not a Delta P. I think it's like a something 276 or something like that, the Cure one. And what that does, it actually looks down. If you ever seen on the Copeland compressors, they have a sight glass right where the crankshaft would be, and you can see the cup actually filling up within those compressors. They have a similar type oil system where it has a disc on the front. The disc has two little notches in there and picks up a little bit of oil, slings it up, and then falls down within the cup that's sitting right there, and then just drives that oil right down the crank. I have seen, I've never seen one of those fail where it actually failed, except for when you lose a whole bunch of bits and pieces within your compressor. That's the only time I've ever seen that happen. A guy from San Antonio was calling me. He's like, Brett, I don't know what the hell is going on with it. And I was like, man, I don't know what to tell you. It was a CO2. It was a Cascade compressor. And he critical. And he finally opened it up. And, there was lots of bits and pieces of everything. Pistons and that big fancy disc that was in there. I guess he found that the crankcase heater took a poopy.
One thing about these, if you have the optical eye on the end of the compressor, where it's looking at the oil splashing, now if you have foamy oil, that will nuisance trip out on you. And you could have foamy oil for a lot of different reasons. You could have too much injection on the oil. It's getting too hot and it's injecting too much oil into the compressor. The level gets too high, and then when the level gets too high, that the crank starts hitting it, and it'll make it foam. You could have liquid refrigerant making it foam, which is generally the most common, but overfilling could make it foam, and then when it foams, it causes nuisance trips with the optical eye, the OC. What was it? OC.
Oh, it's like
OKC1 or OLKC1.
Something like that.
Yeah. So that'll cause nuisance trips with that. So just be mindful on these slinger compressors that you don't have that in there. I personally don't like the optical eye. I'd much rather have an OMB on it on the side and use that for the oil. If there's no oil in it, if there's oil in it, it should work. You should be getting oil to it. Like the foaming causes nuisance trips and with the optical eyes.
Since we're talking about what else is going to cause that oil to go off on me.
So you could be contaminated oil could cause it. Moisture can cause it. Liquid refrigerant is most likely the most common cause. And then the crank hitting it. If it's too high, the crank hits it and stirs it up. And then next thing, the oil's foamy.
Yeah. By the way, when I was talking about the green compressor that breaks because of the high compressor, it was a Carlisle. Wasn't a Bitzer. Someone called me up. They're like, you were talking bad about Bitzers. I was like, no. Those are, you can fill them up. You're not supposed to, but I've seen where they have a little bit more oil in there. It's not damaged. It's the Carlisles where you go anything over half and it does not like it. Where exactly what Kevin's talking about, where the crank will start hitting the sump, the oil that's in the sump, and start just foaming up the shit out of the oil and breaking stuff.
Every compressor is going to break when it gets too high. Cranks spinning at whatever 2100 RPMs. Whatever they're spinning at, like when it hits a solid surface, basically, it's going to cause carnage. Nothing is going to, it's like hitting a concrete wall at that point, that fast.
Yeah. But Carlisles will break more, just saying. So one of the other things that might be causing intermittent compressor failures is, bad valves. And it might not seem like it's actually blowing by. A lot of people think doing a pump down test is the way to check your valves. Okay, that might work on the suction valves, right? But how's it going to work on the discharge? So you essentially have to check via using the Copeland mobile app and run it, or the Bitzer software, and seeing what the amperage is supposed to be at that particular point in time. And also make sure the discharge temperature is correct as well. You'll see a variance in your discharge temperature of what it's actually supposed to be.
Yeah, I don't know. I hate the pump down test. I would much rather use the COP charts. Every compressor manufacturer has them. Most of them are online now. If Bitzer can get around to making an app, that'd be great. That has everything in there, like the Copeland app. The Copeland app's awesome. It gives you so much data on that compressor to be able to judge it. Brett said, yeah, you may be able to do a pump down test and see if the suction valves are good, but it ain't going to tell you if the discharge valves are good. So That's one thing that'll cause an issue with that. Another thing is failure to starts, which is like a nuisance thing after power outages. If you don't start and something happens to contactor or the compressor missing a phase and it doesn't start and then it trips out on oil, guys will go there, hit the oil switch, it may be fine. That's one thing to keep in mind. Like after power outages, sometimes you may get some nuisance trips on where everything's tripped on oil because the compressor didn't start. They may have had bad voltage and the phase loss monitor didn't pick it up, and it tripped out on the oil control.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Now, this could be prevented, and a lot of racks do this. They put a current sensing relay or some kind of relay in line to break power going to the oil control for the 240 or the 110 neutral. So that way the oil control can't time out until the compressor's running, until it sees amperage or there's a contactor is pulled in, there's a proof on the auxiliary side connector. So that makes things difficult when you're trying to test oil controls because you can't just shut off the breaker and test it at that point. So you either need to run it out of oil to test it, or you need to jump out the current sensing relay in order to get that voltage to it. So you could test the oil control to make sure it times out. We were just doing this retrofit, this controls retrofit, and I was going through and testing stuff, and I rewired a ton of stuff in the rack, and I was testing the oil controls to make sure they worked, and 3 out of 5 of the oil control relays were bad. Meaning, like, there was a relay, so until the contactor's pulled in, the auxiliary side connector sends voltage to this relay, and then the relay closes once the contactor's on, and it sends voltage down to the oil control. 3 out of 5 were bad. The relays are burned up.
So what, they were never oil filling?
They would never oil fail.
I wonder how many compressors they went through.
There's 2 brand new ones in the rack, and 2 of them are on compressors with bad sensors or bad relays, and nobody ever tested it.
That's awful.
So that's a big thing. If you guys, I'm big on testing every component for putting a compressor in. I don't want to do it twice. Make sure that oil fail switch actually fails out and shuts the compressor down, and there isn't something crazy going on, or somebody did the old oil control delete.
No one ever does that.
Never really seen that till I went down to Texas.
Come on, don't say that.
Some guy looks at me and goes, "Oh, I'm going to do the oil control delete." I'm like, "Ha, funny. He did."
Come on. Doesn't work out, jump it out.
Yeah.
Everyone, I was joking, so don't fucking do that, okay?
I've seen janky stuff. I've seen wire nuts shoved in compressor contactors. I seen a service manager one time tell an entire group of guys to at least use a zip tie. That way the customer doesn't see that you shoved the screw in the contactors because you couldn't figure out why the compressor wouldn't run. Yeah. Hey, I came unglued in front of a bunch of people about that. Use a zip tie so it's not so obvious.
Hide that you're trying to just jump out the thing that you don't know what you're doing. Just do that. Awful.
Don't do any of that.
I know, seriously. We were just joking. I'm going to get a call tomorrow. You know what this guy heard on the ARP?
Condenser fan motors are one thing, though.
Stop it. Jesus. Where's my thing?
I've jammed some condenser contactors in before. They all burned out.
Stop it.
It always seems to be the 208 stuff that trips more on oil when after a power outage. You usually don't see the 110 stuff doing it. It's just the 208 stuff usually ends up having more power problems when it goes to start up.
All right, let's get off jumped out contacts. Blocked filters, blocked oil filters can potentially cause some kind of oil issue. You're not getting, especially in the summertime when you're using your compression ratio is higher, you're using more oil. In the wintertime, it was fine because a little bit of oil here, it was using a little bit of oil here, now it's using now. Everything's hot as hell, and now we're running full tilt. So, yeah.
Don't use bypass filters. I know we said this before, and a million times I'll die on that hill.
Yeah, because then it blocks up, and it's fine. We'll just let it go, and then it bypasses. Then you're shoving a whole bunch of crap down the line.
Yeah, and then all the screens start plugging up, and I don't know about you, but I hate pulling the screens on the oil pots because it's so messy, and sometimes they don't seal back up, and they're in really shitty spots sometimes where you got to make custom wrenches.
Yeah, I was looking for the picture of the one that I have. I have a 10 millimeter and a 7/16 that looks like a dog was chewing on them for about 20 years.
Yeah, I've bent a couple 10 millimeter wrenches, and especially like the Costco's where they did the scroll to Bitzer changeovers. Some of those are so tight because guys didn't pay attention when they did them. And think about it, like it's almost impossible to get the bolts out of the side of them sometimes without bending a wrench at a 45-degree angle.
They lined up the compressor. They're like, oh, it's going to fit just perfect. And then forgetting that you need another 8 inches on the side for that fucking oil pot.
Yeah. And then if you got the Crewan ones, you could just punch yourself in the head because they're Allen keys and their bolts are like 4 inches long. So trying to get them out, good luck.
Lovely. You can have a bad oil pump. You can. I've only seen it happen about a handful of times. I don't know. So I can't get a true blue answer on this, but I've heard this several times from several different people where a Carlisle compressor, we've had one right out the box, brand new. And it wasn't one of those brand new ones that you hate, Kevin. It was an actual legitimate brand new. Wasn't
Do
a
you even
reman.
make those anymore?
The remans?
No, the brand new ones.
Stop it. Anyway, so I hate you so much right now. So anyway, I can't even think what. Yes, I remember. So on some of the compressors, like you put a brand new compressor in, and it keeps oil filling. And if you check the oil pressure, you'll have 10 pounds of pressure, maybe even lower. And then just for shits and giggles, switch the phase, and then all of a sudden you got your 35 pounds, and it's just a rolling then.
Yeah, I have never had good luck with switching the phase and getting the oil pressure back. Now, I will say this. Every time I've changed an oil pump, it's a Band-Aid, and the compressor's usually dead in a few more months. It usually buys you a few months. Even on the Copelands, it doesn't seem to, once the oil pump goes, it seems like the damage is pretty much done. The oil pressure usually comes back, but it doesn't seem to last long afterwards.
I think part of the reason, and I might be totally wrong here, but I'm just making an assumption. If you have a bad bearings within the compressor, because remember the crank hooks up to the oil pump, yeah? So if you have bad bearings within the crank and it damaged the pump to make it not pump oil, and then you put that pump on there, it's just going to damage it again. And shortly there, usually after that, because it's been running with shitty oil for how long, now all of a sudden the compressor finally seizes up.
Yeah, it usually doesn't last long after that, and you're 100% right. If you pull the oil pump apart and it's like real loose and moving around, she's going to die again.
Or you see the keyway snapped. That's a really good one to say, oh, I think there might be an issue. If you suspect, if you're just doing it for the service, you're ordering a compressor or whatever, then just do that. But a lot of these compressors are not made to service the lower end, right? They'll tell you that if you want to check the bearings within there, you try to handshake the crank by taking off the main plate. And if you have a lot of wear, then you'll see it within doing the little handshake.
Yeah, be very careful when you're taking that T-fitting off the top of the compressor if you're accessing it. I've broken one of those off on a running compressor before and really hated my life. So you will get a bath.
Oh yeah, same thing with the older. So they don't do it. They don't have them anymore. I guess they deleted it with the new style of the compressors. But on the Copelands, they got rid of the oil cooler. And
oh yeah,
there was that fitting that was like 1/8 inch MPT, and it went to that 3/8 flare fitting. And man, I wanted to just. I was just so mad. So I went there for something else, and I was always like trying to look for something else just to fix something because I don't want to have to like. I don't know. I don't want to have to do something in the middle of the night and there was an oil failure. Or I'm sorry, there was oil on the ground. I was there because a door was open on a walk-in. And I was like, oh, I'll just pump it down real quick and undo that fitting. And El Snapperoo just snapped right off. I went through 4 reefer wrenches, 6 easy outs. Finally, I ended up just having to drill out the fitting, and then I went to a supply house. I was like, hey, can I see one of your bad compressors in the back? And Trey got one of the fittings because they don't sell them readily available.
Yeah, no, you gotta get it from a supply house from a dead compressor or keep them. I always took them off of compressors before I sent them back, and I would keep them in the van. I would have 3 or 4 of them because they've broken off before, and those things suck to get out. The easy out, you got a 50-50 chance of the easy out messing up the casting.
Yeah, so I actually ended up with it isolated. I ended up putting just a little bit of nitro in there, not to pressurize it, but just to have flow. So I put nitro in the crankcase, and then as I'm drilling it out, all the shavings are shooting out towards me. So all the shavings didn't technically go within there, and then it gets to a point where the wall of the threads of the fitting gets so thin that the drill then grabs it and usually shrinks, like just wraps around the drill bit, and then it usually comes out. And then just retap it for good measure.
Yeah, at that point, they're getting a new compressor.
It was a brand new compressor. It was a brand. Get out of here.
Yeah. Yeah, so that's just one thing to be mindful of when you're taking that stuff off. And then the other thing to be mindful of if you guys are having oil failures is one of the crankcases pressurizing and causing all the other ones not to feed. So if you have oil equalization lines and you have one compressor with blown rings or that is pressurizing the crankcase because the piston's no longer in the hole and it's just a giant hole there, and this is blowing through and pressurizing the crankcase, you'll feel warm, hot gas on that equalizer line. That's your telltale sign. You'll hear one compressor blown through, and as soon as you valve that equalizer line off, generally all the other ones will start to feed oil again because that's keeping the crankcase pressures all higher than the oil feed line pressure. That's 20, 30 pounds above your suction. So that's one thing to keep in mind. I usually valve those off because I have had so many problems with them. I'd rather one compressor get taken out than all the compressors.
Yeah, so you can see this little animation. We were going to talk about this later, but it's fine. So if you have this compressor go bad, and then the pressure essentially goes back down, it's going to go back in within the crankcase, right? And then when it does that, it's going to put pressure all within the equalization lines, all to the rest of the crankcases. Essentially will raise the pressure of all the crankcases, raise the pressure of the equalization line, and that compressor is not a feed. It's not getting any oil, any of the other compressors. And like I said, you'll see, if you look in the sight glass here, you'll see on a typical running system, you won't see any mist or any smoke. It's just the misting of the discharge gases going back within the crankcase. If you see that and then you shut down one compressor and it stops, it settles out, chances are that you isolated the compressor that was essentially bad.
Correct. Yeah, that's one thing to look into. And if you have on a high pressure system or anything that the oil lines are pretty warm and you have one compressor overfeeding, it's usually pretty easy to figure out. If the oil's pretty hot, you could usually put your hand on the line feeding the pot. It's usually pretty warm, and that's usually a general indication that compressor is overfeeding and taking all the oil and using more oil than the other compressors. Mm-hmm. If they're cooler, because they aren't getting that oil because their pots are closed down, or oil floats are closed down, however you want to say it. It generally shows up easier on a high pressure oil system or a combo separated reservoir It's a little bit more tricky on a reservoir style system where it has a separate reservoir, because usually that oil cools down it by sitting in the tank in the room. Usually the oil cools off, and it's a little more tricky to troubleshoot.
What you'll see is too, though, if you have that situation, it might be a little bit harder to catch in the summertime, because you're constantly feeding a little bit of oil back to the reservoir. But you'll find a lot of times where, like, whatever one is feeding is basically sucking all the pressure from here down to basically suction or crankcase pressure, right? And then you don't have enough oil pressure to push an out to the rest of the compressors that they're not overfeeding.
Yes, that is 100%. In general, you can feel it with your hands or a temp clamp. And then my way of setting up the oil floats and testing them, I generally set them to what they should be for the manufacturer, and I watch them. If it ain't coming down the suction, and I usually test it by shutting off the oil float. If it stays level for an hour, then you got oil coming down the suction. If it starts to drop off right away as soon as you shut the oil feed line, then something's wrong with the float. If it's not maintaining and the reservoir pressure is correct, or the oil pressure regulator on a high pressure system is correct, and it's still feeding, and after you set the float up to what the manufacturer specs show for that oil float, if it's still feeding, then the oil float's junk and it needs to be replaced. That is how I judge them when they need to be replaced, if they're overfeeding.
And then using your temp clamp, we talked about this weeks ago, but you got this little method here of checking to make sure that you actually have oil feeding on your low pressure systems. You can put a temp clamp right on your oil line coming out of the bottom of the oil separator.
I recommend at least being 2 feet away from it, so you don't get any conductive heat.
I'll move it down a ways. But yeah, so you should see this go up in temperature. You'll see it go up and then down and then up and then down whenever that thing is actually feeding.
Yeah. Now, you should be feeding a couple times an hour minimum in the wintertime when you're really moving slow. In the summertime, you should be cycling quite a bit. When I do an EMS retrofit, I add a temp sensor on every oil line. So that way I could graph it via the discharge, and I could see when the oil float opens. And if I don't see it opening at all, and it's just hot all the time, then we probably got a stuck oil float. Or if it's stuck open oil float, and if it's not opening at all, it's probably stuck the other way. You hope it's stuck the first way, so that way you could fix it not at 2 o'clock in the morning. And it's just an emergency. Still a problem, but it's not a 2 o'clock in the morning problem.
That's your hope until someone's, what's this oil thing that's happening? Oh, we don't need that. We can shut that off. We don't need it.
Yeah, so that's the hope of it. Now, this is a pet peeve of mine, which I see guys do this all the time. They will check the pressure drop on an oil dryer. 90% of the time, it's going to have no pressure drop, even if it's plugged. Because here's the problem. If there's no flow through it, or the oil float's not calling or putting it there, it's not going to have a pressure drop. So if the oil float's not filled up and allowing discharge gas behind that oil, you're not going to have a pressure drop on an oil filter. So if you think there's any chance, change it. Change it. Oil filters are cheap. Oil filters are good insurance.
Why don't we put 2 of them in there?
Oh my God. We just did this retrofit, this control retrofit, and I look over, and I was only there for help for a few days, and I'm like, what the hell is that? And they're like, oh, you just seen that now? There was 4 OF303s in parallel. I'm like, who did this? It was obvious that it was done in the field. Some service guy did it, but there was 4 OF303s. Yeah, they keep plugging up, so the guy put 4, in-house guy.
That's amazing.
$900 worth of oil filters is like all teed together. I go, so they all slowly plug up at once. I go, this is interesting.
Just moves down the line. One gets more of a differential.
Now it lasts a quarter. Now it lasts more than a quarter. It makes it from maintenance to maintenance now.
Until it's fully jacked up.
Yeah.
All right. Let's do one more oil one.
Yep.
We're at 47 minutes. We got pretty much more stuff to do. So let's do another one, and we'll continue with this series. How about that?
Yep.
All right, guys. See you guys next time.